Hi, this is Andrew. Today we're going to cover state management in Angular using a library known as RxJS and their associated utilities known as Observables. So let's begin. To start off, let's go ahead and make sure that Angular is installed, or the Angular CLI is installed on our machine. What this will do is allow us to create a project and quickly get it going with the latest Angular libraries that are available. So if you go to this website, it'll give you quick start instructions. So what I'm going to do is I'm going to open up a terminal. On Macintosh and Linux, the commands will be a little bit different for navigating the file structure, but it's pretty much the same for the most part. So you can also use git bash on your Windows if you prefer, but we're doing some pretty simple stuff, so I'm not going to bother. I'm just going to use the default terminal or command prompt as they call it. So let's go ahead and install. Oh, I already installed Angular, so let's just go ahead and create a new Angular app using Angular 6 and RxJS 6. So we start by typing ng new and then the name of the app. I'm going to call my app State Management. So go ahead and hit enter. And the command line tool will go ahead and create as a project that will, and it's automatically installing all the NPM bundle modules. So that'll take a minute. And once it's done, actually, I'll go ahead and open it up in WebStorm while we're waiting, because the project is already created. It's just installing the package dependencies. So we're opening up my editor of choice, which is WebStorm. JetBrains makes a pretty good set of IDEs. WebStorm is normally for like JavaScript projects. IntelliJ does everything that WebStorm does, but it has some extra Java features. And yeah, so this will take a minute. And in the meantime, I'm going to go ahead and show you the RxJS website. So this is currently it's a beta site for the new version of RxJS. And I took a quick glance at it, and it can tell it's a beta site because it doesn't have as much educational material as the original website did. So that's where I come into play for helping you learn how to use RxJS for state management in Angular, because the website, you can use the old website for learning, but the new website is typically what people would want to use. They want to use the latest and greatest. So I'm going to go ahead and give you a quick demo about how to use this library to manage the application state at the front end of your web application in an Angular app. Now, RxJS is actually included in an Angular app by default. So I'm going to go ahead and open it up. It's on my desktop. And state management. Okay, so we just created this project and now we opened it up. So I'm going to show you, once it opens up, that in the package.json file, which defines all the dependencies, we can already see that RxJS is included by default when we created the app via the Angular command line interface tool. Okay, so here's a project. We can navigate into it here. And normally we just focus on the source folder, but first I'm going to show you just the package.json file, just to illustrate that RxJS is indeed included by default. So you can see here RxJS version 6 is included by default with our Angular app. So RxJS is actually used by the core Angular libraries behind the scenes. It manages like the whole reactive nature of the application. So you actually don't have to include any new libraries in order to leverage the capabilities of this very useful utility that is included by default with the Angular ecosystem. So let's continue. Let's go into the source folder and the app folder. So this is like the basis for the actual application. It's where all the HTML file and the controller, or what you would think of as a controller code would be, as well as the module, the core module, which is where you kind of register all your components, services, and filters, and anything else that your app might be using. Okay, so let's go ahead and start this up. I'm going to actually go back to my terminal. Oh, it's still installing. Okay, my internet's apparently a little slow. So what we're going to do is I'm going to start by just creating a couple more components and render them on the screen. And that way we can get started on managing the state of each of those by having some data that we'll kind of distribute to each of them and render them differently on each of the different components. Okay. Since we have a minute, it's still loading. I'm going to go ahead and show you something else called NgRx. Particularly the NgRx store. So what is NgRx? Unlike RxJS, NgRx is not included by default with in the current version of Angular. Maybe in the future they'll have some sort of similar thing included, but as of right now, NgRx or any similar Redux library is what it's called. There's no Redux library included with Angular by default right now. So just so you don't get the names all confused, RxJS stands for reactive. That's the R. X is extensions. So reactive extensions for JavaScript. That's the JS at the end. NgRx, well, the ng is very often associated with Angular, and the Rx. The Rx is also just reactive extensions, but this is a library specifically designed for managing state application. It actually builds on top of RxJS, and it's more sophisticated. So for a very, very small app, you might not really need NgRx. RxJS can do everything that you can do in NgRx, but NgRx is like a more well-defined framework for how you manage the state using like only one state object, for example. And with just RxJS, you can do kind of whatever you want. You can have a state object in each of the services that you have in the app. But we'll go more into detail on what that all means. So don't worry about that. I was just kind of giving you an overview on what's out there while my node module is installed. So let's take a look at my terminal once more. And wow, it's still going. Okay. Oh, it made some progress. Okay, cool. It looks like it's just about done. Okay, cool. It's all done. So we went ahead and our app should be ready to run now. So I'm just going to go into the folder. So cd state management, and I'm going to npm start. This is a npm script that's defined in the package.json file, which will also run the ngserve command, which some of you may be familiar with for those of you who have worked with the Angular command line tool before. So you can see here that behind the scenes it actually ran ngserve. All right, so while that gets started, I'll go ahead and open up a second terminal window or command prompt window, because this is going to be running in the background and we want to be able to actually have use of our command line. So I'm going to go back into that same folder, and while that's running in the background, you don't have to worry about it anymore. It'll just kind of rebuild as you change your code. So what I'm going to do is I'm going to use the Angular command line interface to create a couple components. So you're going to type ng generate component, and then I'm going to, if you see our project structure here, everything's going to go within the app folder. And if you want a component to go within a subfolder, you first type the folder name. So I'm going to call it food, because I'm going to focus this demonstration around state management of a food app. So we're going to put this component into a food folder, and I'm going to call the component great. I think that sounds good, because we're going to have great food. I'm going to make another one for awesome food or something like that. So I hit enter, and if we go to WebStorm, it might take a second, depending on your computer. It's normally not this slow. I'm running my video recording software also. I might be slowing my computer a bit. Okay, so you can see I went ahead and created these HTML file, the spec, the JavaScript or TypeScript file, which is basically the controller, and the CSS file. So you can see in WebStorm that it created our food folder, and within there it created a component called great. Every component also gets its own folder. So that's part of the rule of one, which basically states that every component should be kind of grouped together in functionality. That's part of the Angular style guidelines. So let's go ahead and do the same thing, except let's call the next component. I'm going to show you a shortcut actually. Instead of typing out generate component, you can just type GC, and that's the shortcut abbreviation. So food, this one's going to be awesome. Okay, so we're going to go ahead and have these two components, and if you take a look at the TypeScript file, it'll show you the selector. The selector is what you use in a given HTML page to render this component onto the screen. By default, the Angular CLI will prefix the word app dash in front of the component name. So for our great component, this selector for it is app dash great. So I'm going to go ahead and go into our root application HTML page. And I'm just going to delete everything. We don't need this boilerplate code. And I'm just going to go ahead and type app-great, because that's the name of our component we just created. And I'm going to save it. All right. So now if I go to the web page, it should be running on the localhost port 4200. I had a previous app running beforehand, just ignore those errors. Okay, cool. So now we can see great works, and that's the default text for a given component when generated by the Angular CLI. They put the name of the component and then works exclamation mark, as we can see in the HTML. Cool. So now we're rendering that onto our page. That's great. Now let's go ahead and render this awesome component as well. So just go ahead and type app awesome. And this is a shortcut called emit, which you can just type the HTML element name and press the tab button, and then it'll automatically create the opening and closing tags for you. That's a plugin for many IDEs. It's default. It's installed by default in WebStorm and other IntelliJ or in other JetBrains programs. Okay, so I go ahead and save that and go back to the web page. It'll automatically refresh and reload my page with the two components that we have. Great. So now we have two components. Now in order to represent state, we need some data, because state is basically a composition of various data elements. And once we have that state or data, we can then render it accordingly. So let's go ahead and I'm going to use a data service, or just simply a service. So I go back to the command line and type ngGenerate, or just G for short, S, which is short for service, and then the name of the service that I want to make. I'm going to put it in the food folder also, and I'm going to just call it food service. So in the food folder, and since we already have a food folder, just typing food here will put it directly, the service directly in the food folder. It won't create a food folder within a food folder. So that's all we really need to type. And you can see once it's generated, it'll put it directly in this food folder here at that level. In the meantime, I'm gonna go ahead and create another file in here also. Right click. I accidentally clicked on something. All right, so I'm gonna go ahead and right click on there, new file. And I'm gonna make a model file. This Angular doesn't recognize what a model file is. This is just a kind of convention I've picked up from some online training videos from some other people. But it is a good way I've found to organize your interfaces for that kind of define the structure of the data that you'll be receiving. So in order to make this realistic, I'm going to make a food model file, which will define the various attributes that our food object will contain. And this is kind of going to be mimicking some kind of data that we're going to be getting from a server. So I'm going to go ahead and click OK. And we're going to export an you can say yes, add the file to Git export interface food. So TypeScript allows you to define interfaces. This isn't a native JavaScript thing. So what I'm going to do is define the various attributes that I want to include in this food object. I'm just going to make some stuff up. It's nothing too particular. I don't know, maybe flavors. Let's make that a string array. So as I mentioned, this is a TypeScript file, so this isn't really an introduction to TypeScript. I will point out a couple of things here and there, but you might want to watch a primer on TypeScript if you haven't already. Okay, so otherwise you can just follow along, and I'll try to keep it fairly elementary. Okay, so when you get a response from a server after logging in or going to a certain page when you're already logged in, then you get a bunch of data back from given APIs. So say like we're on a food website and we, I don't know, get a bunch of flavors, we get, I don't know, meats. It's also an array of strings. Some random other stuff. Let's give that a string. And preferences. Okay. So the red squiggly usually tells you what errors you have. Here it just wants an empty line at the end of the file. That's thanks to the TypeScript lint. Is that JSON? Okay. So we got our an interface that we can use for defining our food object. Okay, so now our service should have been created by now. It was running in the background. I don't know why my computer is so slow today. It shouldn't only take like a second to create a service. So anyways, in our food folder, what did this do? Oh, look at that. It actually didn't put it in the food folder. It put it at the root of the application, which is not what I wanted. So I'm going to delete it. I could just copy and paste. But let's do it again. So food/food. That should put it where we want it. And, okay, there we go. That's fast that time. Okay, so now in our food folder, we have the model file, which defines the interface, and we have the food service and some unit test file, which we're not going to cover. Okay, so I'm going to open up the food service, and I'm going to use something called the HTTP client. And I'm going to inject it into our component or into our service in the constructor function. And a good IDE such as WebStorm will prompt you for most of your imports. So I'm going to choose it from the Angular library. As such, okay. So now we have that imported. In order to actually use this, any kind of service, you actually need to go to your app module and register it in the providers array. So first of all, we had a food service as such. Was it food service maybe? Yeah, there we go. Import it. Get rid of this one. Okay. And also, we're using the HTTP client, which actually needs us to import it in this section as the HTTP client module. You would get some errors in the browser if you tried to run your application without doing this. So it'll kind of basically tell you what you need to fix in order to get it running. So if you forget, which a lot of people do, don't worry. It said service twice here. Should say food service. Okay. So a lot of times you just got to look at the JavaScript console when running an Angular app. All right, and that's spelled wrong for some reason. And is this not working? Oh, what's our service name? Food service. Okay, it was food service, not food service. Okay. I don't really even know what the plural of food is. It feed or foods? Or I'm just going to call it food for lack of caring. All right. Okay, cool. So now we got no errors on our application module. So everything's registered correctly within our Angular application is what that means. So now that means that we can actually use our HTTP client to retrieve some kind of data from the server. So what I did was I did a Google search for random word generators, and the one I used previously wasn't, it was giving me a 404, it wasn't running anymore. So I found this other one. It was very low hassle, you don't have to get any API key or anything. It's free to use, so I just went ahead and I'm going to use this one. It basically generates random kinds of meats, which is actually why I decided that I was going to go with a food application as the topic of choice. So I'm going to go ahead and copy that, and I'm going to do a GET request. So HTTP. Oh, if you use the this.http client. Now notice it's giving me red squigglies. That's because in order to use a class variable, in order to inject it properly, you have to give it a access modifier. So I'm going to give it a private access modifier, and then notice down here it's registering it correctly. So I'm going to do a GET request to I'm going to paste that URL. Forgot to check the quotes. Okay. And I'm going to give it there's a option that we need to pass it so that we know, because our API is actually returning just a string. It's not actually returning a JSON object. So the HTTP client by default expects a JSON object. So we're going to pass an object and give it a response type of text, like that. Okay. So what we're doing here is we're going to fetch some data. However, in order to give you a good idea of what happens as an application state changes, we're actually going to do this every, I don't know, a couple seconds or so. So I'm going to use the standard JavaScript function called window.setInterval, and we're going to pass in a function. Created too many brackets for me. Okay, so we're passing it a function and the interval. I'm going to give it let's give it 1800 milliseconds. And now I'm just going to paste this in up there into our function. And correct any brackets that are missing or excessive, or missing a parentheses there, I think. So that's the get request. No, that should close the, hold on, I'm missing a bracket here. Okay, so in the constructor, we're calling the setInterval function, passing in this function and 1800. And I used the parentheses there. I'm working on a small Windows monitor, so I couldn't tell the difference between the bracket and the parentheses. All right, so anyways, that closes that, and we don't need that. Okay, cool. So now we're every 2 seconds or so, we're gonna do a GET request to the API of my choosing, and then this utility actually returns an observable. You can see on the bottom right corner of this helper window, it's an observable type string. So what I'm going to do is I'm going to subscribe. Oh, sorry. Let me undo that. The GET request returns that, so I'm going to go on a new line and subscribe. So I mentioned the word observable. That's actually what a lot of this video is going to be about, is observables and behavior subjects. So this actually goes to show you about why and how important that observables are. The default HTTP client provided by Angular, the Angular core library, or Angular common library, it uses observables. That should give you some kind of a hint as to how important it is to understand observables and how to best use them and benefit from the features that the Angular team provides for you to work with them. Okay, so now we're getting our data. So we're going to pass that data into the subscription function. I'm going to call it response and give it a type string. So I said it's of type observable, but the subscribe function actually takes the data out of it. So basically, you don't have to work with observables inside of a subscribe. Okay, so and within that subscribe function, I want to just edit the data a little bit because um, if we go to this API again, you can see it's kind of a weird looking set of data. It's not like an array of, actually it is actually an array of strings. I didn't notice that before. But I mean, I kind of want to just work with one word at a time. So I'm gonna go ahead and just modify this data from the API just to make it a little more simple, so to speak. I'm basically gonna get rid of the bracket, and then I'm just gonna split it by the spaces. So let's go ahead and do that real quick. I'm just gonna say response equals response dot replace, and we're going to replace the left bracket with an empty string, and we're going to replace the right bracket with an empty string. And what else? You see these squigglies? It's just TypeScript wants you to put a space before this. Okay. And then what else? Let me think. Okay, so let's just split it by a space, and then that should be good enough for us right now. Okay, what is it complaining about now? String array is not, okay. So yeah, we got to use a new variable now. So let's call it data array or something, I don't know. Data, sorry, it's which is a string array. Okay, and we're gonna put some of this data into our food model. This is just kind of a way of mocking what an actual some actual data would look like coming back from a server. So a lot of this is just you getting to see how we can set up some mock application state. So what I'm going to do is I'm just going to const food equals, sorry, we're going to use the type food that we defined, and we're going to set it equal to something. So you get the reg squigglies because you didn't implement all the attributes that are defined in our food model. So we need flavors, meats. Flavors is going to be something. Meats is going to be something. Random other stuff is going to be something. And preferences is going to be something. Okay. Cool. So next up, let's take some of the data from the data array and put it into here. So flavors, what is flavors? Flavors, go back to our model. Flavors is a string array. So we need a string array here. So I don't know, let's take a couple items or a few items from the food array, or from the data array. Data dot, it's got to be some kind of way to take a subarray. Hold on. And as I mentioned, there is the JavaScript slice method will create a shallow copy for us. So let's go ahead and use that instead of just writing out a few of them. So I'm going to go and use data.slice. The start index is going to be 0. And let's end at 3. Yeah, that'll give us 3 data elements. And for the meats, let's go with data.slice. And let's start at element number 4 and go through 8. Let's make it a little bit higher in the numbers. That should be good. Okay, cool. So we get some data into those. Other random stuff is going to be data. I am cool. And preferences is I prefer to be myself. Okay, so this is just kind of some dummy stuff that'll represent the state of an application. Okay, so let's go ahead and kind of try to render this data somehow. So let's go to one of our components to begin with. Let's try with the awesome component. We're going to go to the TypeScript file, and we're going to inject our service into this in the constructor. We actually don't even need the ng-on init. We can just work directly with the constructor. Okay, so anyways, let's inject our service. So it's a food service. That's the type. I'm used to Java. So the type goes after the variable name. So food service of type food service. And remember to use the access modifier to provide proper dependency injection. So now, let's go back to our service for a second. We never talked about how we're going to distribute this data through our application. So we're getting the data in here, and we're defining it, a food object here, but we're never doing anything with it quite yet. We need to have some kind of mechanism that will allow us to distribute it to each of the components that need the given data. And these components can be like deeply nested within each other. And oftentimes in the past, you'll have what's called a smart component and a dumb component, which means that basically at the top of your application tree, you'd have this component up here which gets all the data, and then in an HTML file, it'll pass in data attributes into each of its children. And then if those children needed to pass it down even further, they would have to explicitly pass it on along in their HTML files. Well, this is a much cleaner way of doing it. You only need to pass it into each of the components that actually need the data. So what we're going to do is we're going to leverage the RxJS library a bit. We're going to use something known as a behavior subject. Now try not to get too intimidated by it at first. We're going to go through it slowly. So in our class, I'm going to define a behavior subject. And we're going to call it food. Actually, since I'm going to make it private, I'm going to call it underscore food and then $. Now what this means is underscore is quite frequently used for private variables. You don't have to use it, it's just a notation. Same thing with the $. The $sign just means it's an observable type. So that might get a little bit confusing because I'm actually going to define it as a behavior subject type, but it's in the same family as observables, so that's why I go with the convention of putting a $sign at the end of it, just to make it clear that it's using the RxJS library, and it's very similar to an observable. So we're going to expect a food object, and I'm going to create it as a new behavior subject. Okay, cool. So now it's just still giving us trouble because it wants a default value to be passed into here. This needs like an initial state, so to say. So let's go ahead and just define like, I don't know, some kind of initial food object. It's going to be of type food. And I'm just going to actually copy our object from over here and paste it here. And I'm just going to, I don't know, bread. Give us some dummy data to start with. Ham and salami. Okay, cool. So now we can go ahead and pass this object to our behavior subject. And it might take a second, but the red squiggly should go away in about a second. Yeah, it'll take a, okay, there we go. So now let's define an observable. So the behavior subject is private. Now, why is it private? Well, in applications state management, there's something called ownership of data, which means that there should really only be one owner of a given data set. There's various reasons for this. Part of it is that it can become very difficult to debug something if each of your components can manipulate the data directly. So this way, by having a food service which is in control of the data itself, this makes it much more easy to debug or manage the state of the data in an asynchronous environment such as JavaScript. Okay, so let's go ahead and define a public version of this called food $. And this is going to be an observable of type food. And we're going to just call the as observable function off of the behavior subject that we defined in the line above. So what this does is it allows us to pass the data, the food data, along publicly to each of the components. So only this behavior subject can actually change the data. We pass data into the behavior subject. You can think of it kind of as like a funnel or an entry point to our data. It's the portal guardian. Only the behavior subject can change the actual data that's coming through the pipe, which is our observable, which is distributed. So down in our service, in our HTTP call, we have our data, so we're going to actually pass it into our behavior subject, like such. Wrong function. Dot next. See, you can see here there are the three values. The one we want is next, which will allow us to pass into the stream of data what our current state is. Cool. So now we're passing in the food object, which is randomly generated words coming from the web API. And it comes into this behavior subject object here, and it's connected to this observable. And the observable is distributed to our components, and the components are then able to render whatever it is they want to render based on the given state of the application as determined by this observable. So you might want to watch that a couple times because it's an important concept to understand. So now that we have this all set up, we have a mechanism constructed for distributing our application state, and we can go ahead and now start making use of this food observable in our components and rendering data according to the current state of the application. So let's go back to our awesome component where we injected our food service. And in there, in our component class, I'm going to define an observable. We're going to keep it as a local variable to the component. I don't know, what should I call it? Let's just call it awesome. spell that right, awesome. And we'll put a $sign at the end, again, because it's going to be an observable. Observable of type string. Alt enter, auto imports. Okay, let's make another one. I'm just gonna store the raw data directly in here. You really don't need to store the entire data objects in each of the components. You only need to store what's relevant to the given component, but just so you can see it step by step, I'm gonna go ahead and store our food object directly in the component as well. So I'll call it food $sign here, and I'm gonna say it's an observable of type string, or actually this one's gonna be of type food. Okay, so now in our constructor function, we have our food service available. And I'm gonna say that food $sign equals food services copy of food $sign. So we're basically pulling the data from the food service into this component. So now we have a local copy of that. We can also say, for example, we're only really interested in awesome $sign or a certain subset of the given data. For example, on the awesome tab on our website, we're only interested in the awesome foods. So I could define another observable such as awesome $sign and say awesome $sign equals, and this is I defined this as a string, I believe. Where is it? Yeah, it's an observable type string. So let's say from the data we already have, let's map something out. So this gets down into something called functional reactive programming, where instead of subscribing to the observable and having a local variable down here of just type string, this is the old way of doing things. And I could say like this .food $sign .subscribe. This is actually called the imperative way of doing things. And we could say like data, and then this old way equals data random other stuff, for example. That would be like the imperative way of doing things. Oh, sorry. I haven't used subscriptions in a while. You actually do this inside of the subscription function as such, and you would need to unsubscribe also from an observable in a component to avoid memory leaks. But that's besides the point. For now, I just wanted to show you kind of like the old way of doing things would be subscribing to each observable and assigning it to a regular non-observable type in your system. While this old way works, it's not as elegant, and you do have to go through the extra steps of implementing the on destroy and unsubscribing to each of the given observables in order to avoid memory leaks. So that's kind of cumbersome. It's a little bit riskier because you always have to worry about creating a memory leak in the first place. And there's some, I'm going to show you something a little bit later on, which is called on push change detection, which basically allows you to have very good application performance as the number of components increases significantly. So let's get rid of the old way of doing things and let's do it the new way using functional reactive programming using RxJS and observables. So now we have the food object in our class and our component class. Let's also get us some awesome data. So let's say it's this food dot. We need to use the pipe operator in this new version of RxJS. And in the pipe operator, you can pass in a whole bunch of RxJS operators, which were inspired by the array operators. So they're very similar. So you pass in a list of operators here. The map function will allow us to take the input of this function and kind of change it to our liking. So what I'm going to do is I'm going to pass in the data, which is going to be of type food. And then I forgot a parentheses. Oh, and we also have to import map from the RxJS library. And I forgot a parentheses here. Okay, so now we just got to return something. So I'm going to return a string that's going to correlate to whatever portion of this app is supposed to represent. So obviously in a real app it'll be a lot more complicated, but I'm just trying to keep it simple here. So I'm going to say awesome, give it a space. Let's use a template literal. And what else do we want to render in here? Let's render I don't know, a few items from the food array, or from the food object. So using string interpolation, let's render food dot flavors 0. I'm gonna copy that and paste it a couple times. And change the index. So we're going to render 3 different foods. It's complaining about something. I forgot the first quotation. Okay. And it's still complaining about something. I think I had an extra space in there. Let me check. So we close that function. Oh, I forgot the bracket. Oh, I had a quotation within the $sign. Okay. There we go. I see what I'm doing wrong. It doesn't like that. I'm doing multiple objects with just spacing by like that. Okay. So anyways, so now we're on this page. We're going to render this awesome string. So let's go to the HTML component and get rid of the sample text. And instead, we're just going to render what was it called? Awesome $sign. Yeah. Now I'm intentionally making a mistake here because I want to show you what happens. So let's go to our application and reload. And notice, instead of saying the data that we wanted, the string that we wanted, it says object. So in order for the page to be able to render an observable correctly, you need to pass it an asynchronous pipe. So what that does is it allows data to flow into there and automatically update according to whatever data is being passed along. I don't know where that quotation mark came from, but it's not that important anyways. So anyways, we're getting the 3 different random words. Now let's go ahead and quickly throw similar data into our great component. So like before, we inject our service, so food service of type food service. And in the constructor, I'm going to delete the ng on in it. We don't need it. And in our constructor, we're going to say, well, we need an observable called great $. It's an observable of type string. I'm not even going to bother storing the whole data into this file. I'm just going to store the data that we want. So I'm going to take the data from the food service. Actually, I wonder if I can just copy it from the other component. Wrong button. Yeah, we can probably just copy this. Okay, so instead of food $, we're using great. Sorry, we're getting rid of this line entirely. Instead of awesome $, we're using great. So we're just pulling out the data that we really want. And we're pulling it out of the food service dot out of the grade object from within there. And what is it complaining about? Oh, I forgot my private access modifier. Okay. And what's the object called within there? I think it's food $. Yeah. Okay, cool. So this time though, let's take some other objects out of there. Let's take the 5th. Oh, let's not take it from the flavors maybe. Let's suppose that this component is dedicated to a different set of data. So instead of flavors, let's do a replace flavors with, I don't know, what's the other one? It was meats. Let's check our food model. Yeah, meats. Let's replace flavors with meats. Replace all. Okay. Awesome. And speaking of awesome, this is actually our great component. So it should say great. Cool. Yeah. All right, let's take a look at it. Refresh the page maybe. Oh, I know. We forgot to render it into the HTML. So go to the HTML, delete the dummy code, and render the great $. Awesome. So this is actually the core concepts that I needed to show you today. So we have gone through and illustrated how we can use RxJS to distribute data to arbitrary components within the application. Notice, for example, that I didn't have to, in our main component for the application, I didn't pass in any like data attributes. Imagine if the hierarchy of your page went like 12 components deep, for example. If you wanted to pass along data the old-fashioned way, you'd have to pass it along in each of the 12 HTML files. So for example, I don't know, like something. This is something. This is kind of like the old way of doing things. I mentioned it earlier. I'm just going to illustrate it real quick. So if we pass that something into the grade component, then in your controller file, you would need to declare an input of type string. Sorry. Let's import it first. Something. Let's have type string. And then once you do that, you can, like, for example, go to the HTML and render it something. See, so that works to pass data from component to component along down the tree hierarchy of components. However, as I mentioned earlier, what if you have, for example, in the grade component, I have 10 other components that also need the same data. I gotta type it out 12 times, and then in each of those 12 components, maybe 6 subcomponents need the data. So it just gets a mess having to deal with passing along data using data binding like this. If you need distributed data and you need it through various components of your application, it's highly recommended to use RxJS to manage the state of your application, so that any component that needs state can just pull in the relevant services data and slice off the portion of the data that it needs. Similar, by slice off, I mean basically we just map out the subset of the data that we need into an observable that's defined on the component itself. This way, it's very easy to manage the state of your application. It's all centralized, so to speak, into each of your services that contain a behavior subject. And you can actually even do it only in one service, so to speak. But if you only have one data object, that kind of is closer along the path of Redux, the website I showed you a little bit earlier today, NgRx. This is kind of the core concept behind NgRx. It's one data store, and it's basically one JSON object that represents the whole state of your application. And within that JSON object, they have different like subcategories for the different types of data that you have. And you can have JSON objects within JSON objects within JSON objects, depending on the various portions of the application state. And your the different components in your app can map out those different subsets of that application data, so that they can then go ahead and render the application according to the state of the application, according to the state of the application data. So yeah, that's the basic concepts. I'm going to go ahead and show you a couple more advanced topics now, though, now that we've covered the core. All right, so let's get started with the advanced topic. So it's actually really simple. All I'm going to do is add an attribute to the component decorator. I'm going to call it change detection. So I had mentioned earlier this, and you can see here there's something called on push change detection. Honestly, the documentation about it is terrible, but from what I've gathered is that if you have a lot of components and a lot of data that's being observed and rendered on your application and changing as your data changes, changing this to on push will make your application much more, use a lot less memory. So if you have a ton of components, your application will be much faster and more responsive. I saw this in action during a school assignment I was given. I had to render like thousands and thousands and thousands of components on the screen, and in a reactive manner. So the app was unusable without setting this change detection strategy. It's much more efficient, and when you're using RxJS in this supported way via their observable strategy, you can make use of this feature. At least that's my understanding, as how I've been taught it. I honestly never was able to find good documentation on it, but I've tried it out. It definitely enhances the runtime. I don't know all the use cases or when exactly you can use it, but when you're using it as observables, I do know that it does support using it like this. It will detect the change correctly and render the components. So if I go ahead and save that, I went ahead and changed it in both of my components, and I go back to the application. Notice you get a couple undefineds here and there. That was just because of the initial object that I defined. I didn't really give it enough data elements in the service. In this one here, I don't know. You can just illustrate the solution for that real quick. So now when the page loads, there's no more undefineds also. Okay. So yeah, now we have the application running with on push change detection, which means it'll be very, very responsive. And if you go to the old RxJS website and take a look, you kind of start to wonder, why are we using a behavior subject? So that's the topic I'm going to cover next. If you don't really care to learn why, you can just stop watching right now. I think that's all I'm going to show you next, is just what exactly it means to be a behavior subject. And why don't we just use a regular subject? Because if you go to the RxJS website, honestly, their new website isn't that great yet. Their overview page is very minimal. They don't. In the old one, it mentioned all the core elements, observable, behavior subjects, and all that. But here they have subjects. So, for example, why aren't we just using a regular subject? And you can see here it mentions that it's able to send values through multiple observables and observers, which is what we're doing. So anyways, why aren't we using a regular subject? So I'll show you why. But in order to do that, we're going to need two different pages on our application, so to speak. And in order to do that, I'm going to need to register some routes. So I'm going to register the router, the Angular router. I imported it, and now we need to pass in an object that's going to represent our application routes. So I'll define it up here. Let's make it of type routes. Good. It has not been deprecated, which means my demo should still work. All right. So it needs a path. We're going to call it, for lack of originality, we're just going to call it the first path. And the component it's going to render is the awesome component. And the second route is going to have a path called second. And we're going to render on that route, we're going to render the grade component. Cool. Pretty simple so far, right? Okay. So in our application component, let's go ahead and render just a couple navigation buttons. Keeping it real simple. Button. And this is going to have just what's it called, for the routing router link. Yeah, that's it. And this one's going to navigate to first. Oops, wrong button. And the second button is going to, as you guessed, take us to the second component. And we're going to actually delete them from here. And in the awesome component, we're going to, or in the great component, we're going to delete that extra input that we had added, because our point has been proven already, or our demo of that has been concluded. All right, so back in here, we're just rendering 2 buttons, and we also need something called a router outlet. This will render whichever component specified by the router link attribute, and it's going to render that into the router outlet section of the page. So if we go to here, and might have to restart the build process since we introduced a few new things. Let me just try refreshing manually. Wow, those are tiny buttons. Let me make them bigger. Where is it? There we go. Button. Style equals width 100 pixels. Maybe if I add some text, it'll make it bigger. Okay, so now I press first, it takes us to the first one, and when I press the second one, it takes us to the great one. I'm going to actually rename them awesome and great. Okay, so in order for this demo to work properly, I'm actually going to need to slow down the API calls a bit, because it's going every 2 seconds, and that's way too fast for me to talk through something. So let's go to their service and just slow down the API calls. Let's have it change every 7 seconds should be good. Every 6.5 seconds. Yeah, that should be fine. Okay. So it's reloading after having made that change. And now, so we're using BehaviorSubjects right now. Now, the page is, this is a single page application, but technically it has run 2 different fake pages, so to speak, where we're not actually reloading the whole Angular application every time I go back and forth to different routes. You can see the icon is never spinning, like when I go like this. The page icon actually spins and it actually goes to a new page. However, when I just do this, it's not actually refreshing the whole application. It's simply rendering the different components. And the data is actually already there because the first time I loaded the page, I loaded data. So every time I go back and forth, it already has access to that data, and it doesn't have to query it again. You can even see that in the network tab if I clear. And see, we only made 1 call so far, and we're only going to make 1 call every, 6.5 seconds, I think. And it's still able to render the data back and forth like that. Now, why is that? The component is actually destroyed when I navigate between them. So right now we have the awesome component that's rendered. When I click on great, it's going to destroy this awesome component. And when I go back, it's going to create the awesome component again. Now, if we take a look at the awesome component, we're kind of attaching it. We're pulling in the data, the observable from the service. Now, but this component is new. It's brand new. It just got destroyed and then created again. And yet we immediately see the data there. Now, how is that possible? It's a fresh, brand new component. Doesn't it need to kind of wait for some data to come through this pipeline? Well, that's the key distinction between a behavior subject and a regular subject. Behavior subjects have memory. These things remember the last data item that was passed through them via the next command. So anytime a component gets a reference to an observable that's attached to a behavior subject, any such component will have immediate access to the previous data that flowed through the behavior subject. That's why when this awesome component gets rendered anew onto the screen, it still has that data there, but they let go of it when I went to the great component, and then when I come back, it takes the data from the behavior subject through the observable and renders it onto the screen. The behavior subject remembers the last object that was passed through it, which in our case was the food object coming from the API. Now, let's go ahead and change it. I pretty much always use behavior subject, but just for the purpose of illustration, I'm just going to show you what happens if I change it to a regular subject. Let's import it. And notice I get a red squiggly because subjects don't have a initial. Actually, I'm going to undo this. I'm going to just copy and paste it so that way I don't have to deal with undoing it later. Undo, undo, undo. All right. So I'm just going to copy, paste, comment out one of them, and here I'm going to change it to a subject and delete the initial value. Notice it doesn't take an initial value. That's because subjects don't retain state. Behavior subjects retain state. That's why they're so useful in RxJS, is they can basically take a snapshot of how your application looks. And you can change it at any time and pass in a new state for any part of your state object. So right now, though, I'm just demonstrating what happens if we were to use, for example, a regular subject. So let's go ahead and just go back to our application. Probably already refreshed, but I'll refresh for good measure. So let me clear that. So we go to the awesome. Ooh, did you see what happened? Before the API was made, it didn't have any data. Let me go to the great. Ooh, what happened? Well, this is a new component. So let's think through what's happening there. Every time I go back and forth, the data isn't there right away, because now that we're using a regular subject, it's not remembering the state of what we most recently passed through that subject. It has to wait for something to be passed into it via the API call. So it waits for the next API call, passes it through into this subject here, which passes it into the observable, which is attached to the subject. And then the component looks at that observable and sees, ooh, there's data coming through. Let's take the data. But unlike the behavior subject, the observable can't pull data from it. It has to wait for the next data to be passed through the subject in order to get anything into the component. the regular subject does not retain data. That's why behavior subject is so useful, and why the NgRx Redux library is actually built on top of the concept of using behavior subjects, because it's absolutely ideal for managing application state. So I believe that was all I wanted to show you. Let me just, I'm going to change it back to using the behavior subject, because that's how you really should do things, at least my opinion currently. If you know something I don't know, please feel free to share, add a comment in the description. And yeah, I mean, with this core foundation of RxJS, you should be able to manage state in a very elegant manner in a modern Angular 6 application using RxJS version 6. NgRx would be something I would recommend studying for any Angular application that has significant complexity. It can be very good for debugging. Actually, speaking of debugging, there's one thing I wanted to show you before you go. It's called Augury. It's a very nice plugin for both Chrome and Firefox, and possibly some other browsers. Oh, well, it's normally a very nice plugin. Let me refresh the page. Why is my page refreshing all the time? Hold on. No, I might need to restart my browser. Hold on one second. All right, so I just needed to open it up in a new tab. I don't know, my browser was going wild. So I just basically open up a new tab and paste in the URL to our app. So this is Augury. It is great when used with RxJS, and actually just Angular in general. You can take a look at the state of your application. So right now we're on the Grade tab, so okay, so I lied. It's not as graded as it is when you're using just regular like string objects or non-observable types. So that's actually a benefit that NgRx offers over just using straight up RxJS, is that if you use a framework like NgRx, you can take advantage of another plugin called the Redux DevTools. Right here, Redux DevTools. I highly recommend checking this out. It basically allows you to open up like a little sidebar on your browser, and where you can monitor the state of your application as it changes through time. So every time your state changes, you can trigger a state change event and kind of go through all the state change events. And it's really, really nice. It's great for debugging. If you ever need to do a capture of the state of your application, you can download it as a JSON file and send it to someone else, so that you can document a bug or something and just send someone the state of your application and they can load it up in their browser. It's very useful for that. As I showed you here, the Augury tool is kind of limited when you're working with observable types. It doesn't really help you out that much. But yeah, the Redux DevTools are definitely better in terms of when you're working with reactive extensions. And the observables and behavior subjects. This library is definitely something to look into. I'm not going to cover in this video. It's a topic all in itself. It's another layer of complexity, but it does provide a very consistent manner for managing your application state all in one JSON object. and it allows you to, since it's done so consistently via the framework, if an Angular developer goes from one app to another app, they'll very readily be able to understand how the application is working because it's all done in a very well scripted and well documented set of best practices. So yeah, that's all I really have to say right now about RxJS. I highly recommend it. And if you have need for higher complexity, you might want to check into NgRx as well. So hopefully, after some key takeaways from today's discussion, is that you now are able to work reactively using RxJS, functional reactive programming, whatnot. Observables, behavior subjects, they shouldn't be intimidating concepts anymore. You should be able to take advantage of some advanced Angular features such as on-push change detection for making your app more responsive, and you should be able to distribute application data throughout every single one of your components in your application hierarchy, regardless of how deeply nested they are within a component, within a component, within another component. And you don't have to copy and paste or pass along data attributes via data binding at all. You can just inject the service directly into each component that it needs some data and map out the data that you want. So that's all for today. I thank you for watching, and if you like the video, give it a thumbs up.